Let's start the class. And in the last period, we have studied about the hybridization and the shape. So let me ask you some questions. Uh, Here I have a question for you that you just need to tell me, write the state of hybridization, write state of hybridization, and shape of the molecule. Shape of the molecule. So the first molecule that we have is H2C double bond O. The second one what we have is CH3F, and the third one that we have is HC triple bond N. Dear students, you need to tell me that for each carbon, what is the hybridization and what is the shape of the molecule. Hybridization of carbon and shape of molecule. Come on, start answer me. For this, for answer A, tell me, what is the hybridization in this carbon?
sp2.
Very good. What is the shape? If we have sp2 hybridization, what is the shape?
Tetrahedral.
Beta sp2 no tetrahedral.
Trigonal.
Trigonal and planar. Trigonal planar. Sometimes we also call it triangular planar. Sometimes we call it as a triangular planar. Okay, next, what is the hybridization for this carbon? Be little faster.
sp3.
And what could be the shape if we have sp3 hybridization?
Tetrahedral.
Very good. Here, what is the hybridization? Hybridization in this carbon?
sp.
sp.
And if we have sp hybridization, then what is the shape?
Linear.
Very good. Now, my dear students, in the last period, we have even studied about the pi bond. So let us revise let us understand the various characteristics of pi bonds. The first characteristic of pi bond is it is made using the orbitals that does not take part in the hybridization. Second characteristic that we have studied is it is formed by sideways overlap. It is formed by sideways overlap, which is also known as the lateral overlap. This is what we can explain that the orbitals that do not take part in hybridization remain perpendicular to sigma bond plane. Thus, these orbitals undergo sideways or lateral overlap. This is how, my dear student, we understand the formation of the pi bond. अभी अगर यहाँ तक कुछ समझ में नहीं आ रहा है तो आप लोग पूछ सकते हैं मुझे, और सब कुछ समझ में आ गया है तो और अच्छी बात है। आप लोग मुझे बताएं प्लीज, कोई डाउट है तो पूछ लीजिए या आप बोल दीजिए कि सर समझ में आ गया, आगे चलिए।
समझ में आ गया सर।
Okay, then some other characteristics of pi bonds let us understand. In the last period we have seen that pi bond, due to sideways or lateral overlap, pi bond has weak overlap. Thus, pi bond is weaker than sigma bond. So suppose, my dear students, we have C double bond C and there are X, Y, Z and T molecules are present. Suppose this one is your pi bond and this one is your sigma bond, and you want to break the bond. Which bond will be break first? Sigma bond will be broken first or pi bond will be broken first? Dear student, I am asking.
Pi bond.
Why?
Pi bond.
Because pi bond is weak. So what happens, my dear students, that this carbon, the sigma bond remains and pi bond is being broken. Now let us say this pi bond is made up of using 2 electrons, and suppose 2 electron goes on this carbon, so this carbon is going to be negative charged and this carbon is going to be positively charged. This is what it happens. And this carbon has got 2 electrons with it extra, which was there because of the pi bond. Then the next thing we need to learn about pi bond is that if this is the sigma bond, let us say this is the sigma bond plan, then you are well aware that the electron cloud of pi bond is available here. So we can have the electron cloud of our pi bond available above and under the plane. So this is how you can understand, my dear students, that this is the electron cloud of the pi bond which is available. So this is what we represented as an electron cloud of pi bond. This is the electron cloud of pi bond. Please remember, my dear student, electron cloud of pi bond. So what we simply understand here is your electron cloud of pi bond is available above and under the plane. Electron cloud of pi bond is available above and under the sigma bond plane. Now what happens? There is something very interesting happens. We know that, my dear student, that in a molecule named ethane, in a molecule, the name of the molecule is ethane. This ethane is your CH3CH3. And suppose you have ethyne or ethene, CH2 double bond CH2. Now this CH3CH3, you can write it in this manner, my dear students. Do you understand what I mean to say? Can we write it? Can we write ethane this way? We can even write C double bond C also in this manner. Now you can see that there is one plane over here, my dear student, in which this all the four atoms are present. Here also we have a plane in which these four atoms are present. Can you see this plane which I have shown you with the... Now if we start giving rotation, suppose we start giving rotation to this plane in this particular direction, this way. If we allow this plane to rotate in this direction, so this kind of rotation is allowed in ethane. Rotation around the single bond is possible because there is only sigma bond, single bond present over here. But here you can see that we have sigma bond, we have pi bond. The cloud of this pi bond is available above and under the sigma bond. That is what we are well aware. So we are well aware that the cloud is completely formed. This cloud which is available above and under this plane, if we go for rotation, if we allow or if we try to rotate this, here also there is a plane. My dear students, I'll explain you the plane. You can see that there is a plane. There is a plane here even. In this plane, all these molecules are available, atoms are available. If you allow to rotate this, in this manner, if we try to rotate this in this manner, what happens? Can you tell me? If we try to rotate the double bond, rotation around a double bond, बच्चों मैं आपसे पूछ रहा हूं, what happens if we try to rotate this double bond, this plane around the double bond? Hello, dear students.
Yes, sir.
What happens if we do it so?
Yes, sir.
क्या होगा अगर हम ऐसा करते हैं? अगर हम ये रोटेशन लेते हैं तो क्या हो जाएगा बताइए ना? हेलो, बताइए क्या हो जाएगा? नो आइडिया? When we try to rotate this cloud of pi bond which is available above and under, the cloud of pi bond which is available above and under the plane due to pi bond cloud, rotation around double bond is not possible. Because if you try to rotate it, what happens? This cloud get disturbed and the bond get broken. I hope you understand. Do you understand, dear children, or not? Hello? Dear students, I am asking something. Please reply faster. If you don't understand, I will try to explain you. But if you understand, we can move forward. Speak up, whether you understand or not. Hello. Be very clear. Okay, no problem. You are not able to hear me? Hello, dear students.
Yes, sir.
Can you see
Yes,
me?
sir.
Can you
Yes,
see
sir.
me or not?
Yes, sir.
Are you able to?
Yes, sir.
Then why can't I see me
Yes, sir.
myself? Okay. I hope you can see me all.
Yes, sir.
Are you all able to see me?
Yes, sir.
Okay. Where is the view? Now see, this pen that is I am having is your single bond. Okay. I want to rotate this. This rotation is possible. I can rotate this plane which is having your carbon and hydrogen. You can see I am rotating it very easily. Am I right or wrong? But now if I pass
Yes, sir.
two different pens through it, if I pass two different pens, just hold, wait for a minute. Now you can see there are two pens passing through it. Can you see these two pens?
Yes, sir.
Yes, sir.
Now if I try
Yes,
to
sir.
rotate, what happens? Will I be able to rotate it? Say yes or no.
No, sir.
No, it will not be possible.
No,
The
sir.
same thing happens even in the case of the pi bond, because when there is a pi bond, there will be multiple bonds available. So if there are multiple bonds available, my dear students, in that particular case, what happens? We cannot allow the rotation to take place. So you can see that, my dear students, this, when we have double bond, are you able to hear me, my dear students? Can you hear me clearly?
Yes,
Yes,
sir.
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 So when
Yes,
we
sir.
have this double bond, when we have at least one pi bond present, due to this pi bond cloud, the rotation around the double bond is not possible. So now we can easily say that the rotation around the pi bond is not possible. Instead of writing double bond, we can say that rotation around pi bond is not possible, or we can say is prohibited. Is not possible, or in the other word we can say it is prohibited. So this is how, my dear student, we understand about the characteristics of our pi bond. One more thing, my dear students, I have just told you about was that this pi bond can be broken easily. What do you understand by it? So whenever there is a reaction takes place, if any reaction takes place in a molecule containing pi bond, first pi bond is broken as compared to sigma bonds. So suppose, my dear students, we have a compound like this: CH3, CH2CH, double bond CH, CH2, CH2 and CH3. Now suppose there is some reaction takes place here. Where do you find the reaction will takes place? Suppose we have this, I'll give the number to carbon 1, 2, 3, 4, 5, 6 and 7. I want to add hydrogen to it. So I will allow hydrogen to be added with this molecule plus H2. So where do you think the hydrogen will be added? You can see, my dear student, that here we have sigma bond, here we have pi bonds. All the other bonds are sigma. Am I right or wrong? Even all the carbon hydrogen bonds are also sigma. So which bond will be broken first? My dear students, which bond will be broken first?
Pi
Pi
bond.
bond.
And where is the pi bond available? Between which carbon the pi
3 or
bond is?
4.
So where do you think
3
hydrogen
and
will be
4.
added? Where do you think the hydrogen will be added?
2 and 6.
Hydrogen will be added between which two carbons?
2 and 5.
Array, where is the pi bond? Pi bond is between which two carbon?
3, 4.
3 and 4.
Then where the
They are
hydrogen will be added?
At last.
Huh? Speak up faster, please.
At last.
How this sigma bond will be broken so that we can add hydrogen? What is written? If any reaction takes place in a molecule containing pi bond, first pi bond is broken as compared to sigma bond. If old bond is broken, new bond will be formed. So where do you find the bond will be formed? Where do you find the hydrogen will be added? As this pi bond is broken, my dear students, the pi bond is available between the carbon number 3 and carbon number 4. This double bond is broken and you can see that this double bond is broken. So the double bond is broken between the carbon number 3 to carbon number 4 and the new added hydrogen will be added to this two carbon number 3 and carbon number 4, and thus carbon 3 which was CH and carbon 4 which was CH becomes CH2. So my dear students, what we can understand from this reaction is that in a molecule in a molecule, reaction first takes place where pi bonds are or is present. And thus, my dear students, we can say that therefore pi bond provides active center. Whenever or wherever the activity takes place, this activity takes place at the pi bond, and thus we can say even that it is the most reactive centers also. So we can even write pi bond provides reactive centers. So I hope, my dear students, you understood this now. Do you understand this or not?
Yes, sir.
Suppose
Yes,
if we
sir.
take
Understood.
now CH3, CH double bond, CH2, and if you add Cl2 into it in the presence of CCl4, where do you find this Cl will be added? So it is very easy for you now to answer that the Cl will be added on which carbon? Carbon number 1, carbon number 2, or carbon number 3?
Two.
Good. So it will be added on both these carbons and it will form Cl here because this pi bond get broken. So there is a possibility of adding Cl and Cl, and this is how the new compound is formed. Now I hope, my dear students, it is very clear to you about the pi bonds. If you have any doubt, you can ask me. Do you understand everything about
No, sir.
pi
No
bond?
doubt,
Understood
sir.
सर
clearly?
स्क्रीन नहीं दिख रही
हाँ बेटा?
सर स्क्रीन नहीं दिख रही
अच्छा, मैं जो लिख रहा हूँ वो दिख नहीं रहा है आप लोग को?
नो
दिखाई
सर
दे
नहीं
रहा है,
दिख रहा
सर।
दिख रहा है सर।
कोई बात नहीं, मैं फिर से ट्राई
दिख रहा
करता हूँ ना। कोई बात नहीं बेटा, देखो अब दिख रहा है, अभी दिख रहा है बच्चों?
नो
Yes,
दिख
sir.
रहा है, सर।
Yes.
Yes,
ओके।
sir.
बच्चों
Yes, sir.
अभी शायद ओके, तो लेट्स मूव फॉरवर्ड एंड अंडरस्टैंड द नेक्स्ट वन। Okay, my dear students, in the 10th standard, we have studied about the various representation of the molecule. How? Let me tell you. Suppose we have a carbon compound. So we may have this carbon compound. Can you name this compound? What is the name of this compound? Anyone please?
Methane.
Very good. So suppose we have
Methane.
carbon compound,
Methane.
methane. So we will write methane, or we can write CH4, or my dear students, we can even do this way. Now see what I am doing. See, this is even one way to represent methane. What do we call this? What do we call this? We call it as Lewis dot structure. Now from this, what do we understand, my dear student? that two electron is equal to one bond, and bond we represent with this. We can call it hyphen or we can call it dash. So the same methane molecule now we can represent in this manner. This is also possible. Just in the Lewis dot structure, instead of this double bond and circles, we have made just the bonds. So now, my dear students, I will tell you what these are. This is what it is known as the Lewis dot structure. This is what it is known as the structural formula. This is what it is known as the molecular formula. These are the various ways by which we can represent a molecule. But my dear students, suppose we have a molecule named butane. Suppose we have butane. So we represent butane as first C4H10, or we can represent it in this manner. You can see that CH3, CH2, CH2, CH3, or my dear students, we can represent it in this manner. And we can show all the hydrogens. We can show all the carbons inside. Then we put the dots here. So now you understand about this. Or even we represent it in this manner. This way. Can you tell me what these four different ways to represent the molecule is? What do we call it? Any one of you? Hello, dear students.
Yes, sir.
Yes.
What do we call it? इसको क्या बोलते हैं?
Molecular formula.
It is your molecular formula, definitely. This is what it is known as the condensed formula. Condensed formula. This is what it is known as the Lewis dot structure. And this is what it is known as the structural formula.